The decision task we're faced with in this lesson is buying a car. So what we have here is a finite number of alternatives for different cars. Now, although these cars look quite similar, they're different in subtle ways. Different prices, of course, different performance, different comfort, and so on. And no one car is the best along all dimensions. So to make a choice, we're going to have to make some trade-offs. The way we're going to make these trade-offs and make the decision is to use what's called multi-criteria decision making. The technique's also sometimes called multi-attribute utility theory. Both these names make sense, and you'll see why by the end of this lesson. The ending point for this is a matrix, and in the matrix we're going to have a total weighted score. And basically all we do is sort from largest to smallest, pick the highest score, and that corresponds to the preferred alternative. So how do we get there? Well, first we start with, of course, our alternatives. In this case, we have a finite number of cars, only 4 that we're considering. Next, we specify our objectives. This is so critical in decision making, but we want to have objectives and then define these in terms of measurable attributes. So we're going to create a objectives hierarchy, and you'll see how this works. Then we want to assign weights to these attributes. Some are going to be more important than others. Price may be more important than power, for example. So we don't want to use equal weights, but we want to be able to prioritize these different objectives, these different attributes. The fourth step is to compare apples and oranges. That is to score each one of these alternatives along each one of the attributes using common units. Units we're going to call utility. And we're going to understand how utility maps allows us to sort of translate from dollars or millimeters or whatever scale into these common units. Finally, when we put it all together, we get our total weighted score, and we can do this in Excel fairly easily. The first step in using multi-criteria decision making is to define an objectives hierarchy. Now, it's a hierarchy in the sense that at the top we have these fundamental objectives, and then the next layer down we have what are called means of objectives, and then finally at the very bottom we have attributes or measures, things that actually have units that we can count and enter into our matrix. What our job to do at this point is to introspect a little bit and understand what our objectives are. So for example, when looking at a car, I might say, look, I want a car with lots of power. And what we do when we write something like that down in our objectives hierarchy is we subject it to what's called the Witty test, W-I-T-I, which stands for why is that important? So it's very much, a Zen-like practice of asking 5 times why. You see the same thing in, for example, lean management. Ask 5 times why and understand the reason that, for example, power is important. Now, in an organizational setting, it's a little bit more difficult because you're not just talking about your own personal preferences, and that's a little bit tougher. But at least in the personal sense, we can all sort of introspect and say, why is this or that objective important to me? So it turns out, in my case, that when I use the Witty test on power, I really say, well, I want power, first of all, because it gives me some prestige. Yes, I'm that shallow. I want to have a powerful car. So that is one of my objectives, is prestige. And then the other one, might be comfort. When I'm driving and passing on mountain roads, I just like the confidence and the comfort of having a car that has some actual power to it. So what we do now is we apply the Witty test to both these new objectives. And it's okay for the why is that important test to sort of bottom out in the sense that you say, well, why is prestige important? And I go, well, it just is. It's important to me. It's not a means to some other objective. I just want to have a prestigious car, or at least prestigious at a given cost. We'll talk about cost later. Similarly with comfort, when I drive, I want to be comfortable. So both prestige and comfort then can be seen not as means of achieving other objectives, but as fundamental objectives in their own right. Once we're comfortable with our means objective, like power, we can start to think about ways in which that objective could be measured. So in this case, we might want to consider horsepower or torque or something else, but we have to have something we can measure. So I'm going to add horsepower measured in horsepower as an attribute. I can then continue to flesh out my objectives hierarchy. So for example, I may be interested in roominess of the vehicle. And when I think about it, I realize that roominess is just a means of achieving greater comfort. So I make that link. And then when I think about roominess in terms of measurement, I realize that what I'm most interested in is headroom, which is often measured in millimeters. Also, I think about affordability and I ask, why is that important? And I conclude that it just is, that affordability is a fundamental objective, not a means to some other objective. And affordability I can measure here just in terms of the car price. Now, if I was doing this a bit more seriously, I would use something other than price. I would use some measure of life cycle cost that includes operations, fuel, maintenance, and so on. So net present value or equivalent annual cost or something like that. Finally, I would think a little bit about the styling of the car, and I might recognize that that's really just a means of achieving prestige. Now, the measurement of styling is a little bit different. It's going to be entirely subjective. So I might have an aesthetic scale, low, medium, and high. The whole purpose for doing this objectives hierarchy, though, is when you're done and you look at your fundamental objectives, they should be exhaustive. You shouldn't have left anything out, something major. On the other hand, you shouldn't have anything in there, of course, that doesn't belong, although I suppose that could be taken care of in the next step when we talk about weights. Also, when we go look at the attributes, the measures, you want to make sure that they're mutually exclusive, that you're not measuring the same thing twice, because if you do, that's really double weighting that thing. So you want a clean objectives hierarchy that's exhaustive and mutually exclusive. Recall that to do the math in this matrix, we have to assign a weight to each of our attributes. That is a numerical priority. The problem is that people generally have difficulty on such an abstract task as saying, what's the difference between price and power and headroom? Is one a weight of 0.25? Is one a weight of 0.08? That's a very abstract and difficult task for most people. On the other hand, most people are pretty good at making choices when they have two concrete alternatives. If I gave you two phones, you could likely say, I prefer this one to that one, even if you couldn't quite pinpoint the factors or the features or the attributes along which your preferences were structured. You can just make a concrete choice. This is done quite often in market research in which you give consumers the opportunity to make a bunch of pairwise comparisons between products and then elicit their preference function. Now, but this is too complicated for what we want to do. So we're going to do a bit of a shortcut. We're going to use a technique called swing weights. Now, the basic idea of swing weights is that you're making sort of fake concrete comparisons. And you'll see what I mean in just a moment. But you're looking at alternatives that could be real, but these alternatives are constructed in such a way so that the preference structure is much easier to extract. The weights are much easier to extract. In addition, when you use swing weights, you first rank the alternatives, 1, 2, 3, 4, 5, 6, in ordinal way, and then you score. That is, you provide a rating that's consistent with your ranking. So by breaking it up, it's meant to be a slightly easier cognitive task. The first step in swing weights is to get a sense of the range for each attribute. For example, we can look at price and we can see our best price, that is our lowest price, is around $28,000, whereas our worst price is closer to $37,000. So in order to construct our concrete alternatives in the next step, we need to know what range is taken on by each attribute. The starting point of a swing weight matrix is to create what's called a benchmark item. Now, this item doesn't really exist, but we think of it as if it did. And to do that, we specify its values for each attribute. So for example, the benchmark is worst on every attribute. It's the most expensive, almost $37,000. It has the lowest horsepower, which we saw previously was 150 horsepower. It's got the least headroom, and it's the least attractive car with the lowest rating on our subjective aesthetics scale. Then what we do is we generate a collection of other hypothetical items by swinging one by one these attributes. We swing them from their lowest value to their highest value. In hypothetical item number 2, instead of having the worst price, it now has the best price, but it's still the worst on all the other 3 attributes. For hypothetical item number 3, it is the best in horsepower, but the worst in everything else. And so on until we swing all 4 of our attributes. So we're going to end up with 5 of these fake alternatives. Now, the next step is to actually rank these alternatives as if they existed. Remember, the point here is to think about these things as if they were alternatives, as if these were real cars. So instead of looking at the column on the far left and saying, oh, I've swung price, oh, I've swung power, oh, I've swung headroom, I really encourage you to focus on the second column, which is sort of a concrete alternative. Car with a certain price, certain amount of headroom, certain horsepower, and so on. And you say, okay, which one do I like best? Now, this is your decision. There's no right or wrong answer here. This is you looking at these 5 alternatives and saying, which one do you like best? Of course, the benchmark is the lowest on every attribute, so it automatically has to be the worst alternative. So we give it the ranking of 5 in this case automatically, but then we have to pick 1, 2, 3, and 4 from the remaining alternatives. Now that we have an ordinal ranking of our alternatives, the next step is to give each one a rating. That is a number of points between 0 and 100. So obviously the hypothetical item, being the worst on all attributes, gets the 5th rank, and we give it also the lowest rating. We give it 0 points. On the other hand, we know that in this case, hypothetical item number 4 has the highest rank. I ranked it number 1 overall, so it gets arbitrarily the full 100 points. So what the task in this step is is to assign a certain number of points. And you see, this is a little bit more information than simply ordinarily ranking them 1, 2, 3, 4, 5. By assigning points, I get to assign a strength of preference. So for example, my ordinal ranking number 2, I've assigned it here 70 points, which means it's quite a fair drop from my first ranked alternative, which had the most headroom. So then I go down, a hypothetical item number 2 is 65 points. It's quite close. Even though it's third place, it's not that different in terms of points from hypothetical item number 3. And finally, my fourth item, for whatever reason, I'm not that crazy about this one. I only give it 20 points out of a possible 100. So you see what we've done here is really what we want is the rating, but we've broken it into two steps to make it a little bit more manageable. First, we rank the alternatives, and then we select ratings that are consistent with those rankings. In the final step of swing weights, I take the rating for each of the alternatives and divide by the total number of points I assigned through the whole process. So here I assigned hypothetical item number 2, 65 points, and I divide that by a total of 255. And that gives a number 0.25. But now that number can be interpreted as a weight. But because recall where that number came from, it was the strength of my preference as I swung from the benchmark item to an item that in this case was swung on price. So this suggests 0.25 is a measure of my strength of preference for price. If I move down to where hypothetical item 3, where I swung on power, remember I only gave that 20 points out of a total of 255 points. So the implication is I wasn't willing to pay much to swing that from low horsepower to high horsepower. So these numbers then become the weights that we carry forward to our multi-criteria decision-making matrix. So let's just review where we are in the overall decision process. We started with a finite number of cars under consideration, so we have our alternatives. Then we created an objectives hierarchy and identified some measurable attributes or criteria. Then we use the swing weights procedure to assign a weight or a priority number, if you like, to each one of the attributes. So now we're going to talk about this idea of utility maps and specifying a utility so we can score these alternatives. A utility function in decision theory is a way to map from units of something we understand like dollars to units in this other thing called utility. Now, utility is just an abstract measure of preference, or if you like, satisfaction from something. And utility by convention is on the scale from 0 to 1, where 0 doesn't necessarily mean no utility, it just means the lowest utility among the alternatives, and 1 means the highest utility from among the alternatives. So by translating from dollars to utility, it gives us this common unit of measure. Now what we've done here is shown a utility function, or if you like, a utility map for price. And it's both negative sloping and linear. Now, it's negative sloping, which means as the price goes up, as the price of the car increases, naturally utility goes down. The fact that the utility function is linear means, in very practical terms, a dollar is worth a dollar. So that at the far left end of the scale, when we're talking about small amounts of money, a certain increase in price involves a certain decrease in utility, and that decrease is constant as we move along the horizontal axis. So at the high end of the scale, we might see an identical price increase results in an identical drop in utility. Now we can ask ourselves, why is it that we would use a linear utility function for money, given that people's utility for money is highly sensitive to the amount of money they have. So for example, if you're broke and I give you $20, I've made your day. You get a huge boost in utility. On the other hand, if you have $1 million and I give you $20, you're pretty much indifferent. You get very little boost in utility. The argument we're using here for linear utility in money is that this is sort of a corporate environment. And in a corporate environment, we're not talking about personal preferences for money, but we're talking about corporate preferences for money when you can borrow, for example, or get money in different ways, you have less of an emotional attachment to the money, and thus in those situations, we should argue that a dollar is always a dollar, and that is, utility is linear in money. Either way, the important thing about a utility function, or in this case, a graphical utility map, is that when we have an alternative, we can look at its price and then go to our line and read off the corresponding utility. That is, for every car now we can consider, we can map its price to a utility value. Although there are many situations in which a linear utility function makes sense, there are also situations in which a nonlinear utility function makes sense. For example, anytime you have something like a minimum threshold value, or when you have diminishing returns, you'll see that a different shape other than linear makes more sense. So to illustrate this, let's consider the case of headroom in a car. On the low end, as the number of millimeters goes up, the utility stays extremely close to zero until you get to the point at which you have enough headroom. Then once you have enough headroom, you get this idea of a diminishing return. That is, each additional millimeter of headroom provides very little increase in utility. So the result is this S-shaped curve, which indicates a very tight threshold. As before, we can use the utility function, represented here graphically as a utility map, to read off different values of headroom expressed in millimeters and translate those to utility values on the interval 0 to 1. Here in this final slide, we can see the advantage of the utility maps. They provide us with utility values which really allow us to compare apples and oranges. We can compare price to power to headroom and so on. So for example, for the VW Jetta, we can take its value of headroom in millimeters and using our utility map, see that that value corresponds to a utility of 0.40. Then it's just a matter of doing some simple vector arithmetic. We take the vector of scores from the Ford Fusion and multiply those scores by our weights for each attribute, and that gives us a single value, in this case 0.47, which is a total score, or if you like, a weighted average score where the weights are the weights we assign to the attributes. Now, an easy way to do this in Excel is to use the sum product function. Once I've calculated a total weighted score for each alternative, making a decision is very straightforward. I simply pick the alternative with the highest score, in this case, the Volkswagen Jetta.